Welcome to Wisdom Forts Academy.
Hi guys, good morning, good afternoon, good evening from wherever you're watching from. I am Master Steven. In today's edition, we'll be talking about units and measurements in physics. As we discussed in our introductory class, we talk about physics being a branch of pure science under the Department of Physical Science. So today we're looking at units and measurements. Now, measurements are ways in which physics communicate with each other. They are unique ways and system of communication in physics. So talking about our measurements, we have the fundamental quantity and their units, and derived quantities and their units. So today, because of our time, we'll be looking at fundamental quantity. The fundamental quantities and their units. Fundamental quantity are basic quantities that are independent of other quantity, in which other quantity depend on. They are basic quantities in which other quantity depend on. We have about three basic fundamental quantity. They include length, we have mass, and time. Length, mass, and time are the three basic fundamental quantities. What is length? Length is the interval between 2 points in space. From measurement from point A, the distance between point A and point B is length. Length is defined as the interval between 2 points in space. Also, we can define mass as the quantity of matter or stuff in a body. Mass is the quantity of matter or stuff in a body. The SI unit for length is meter. We have other units like centimeter, millimeter, inches, and so on and so forth. So now next class we talk about how to convert units. So today we are dealing with fundamental quantity and their units. So we have time also as a basic fundamental quantity. What is the meaning of time? Time can be defined as that in which events are being distinguished with reference to before or after. You see, we have to and we have after. That is, time cannot occur without an event. It distinguishes an event with reference to before or after. And the unit of time is seconds. Seconds. The unit of time is seconds. You know, we have now elementary class, we have 60 seconds making up 1 minute, 60 minutes, 1 hour, 24 hours make up a day. So in today's class, let's really look at the fundamental quantities and their units. Other fundamental quantity and their units. Also, we also define fundamental units as basic units upon which other units depend on. Fundamental quantity as basic quantity in which other quantity depend on, and which other quantity are being derived from. So because of our time, let's look into our fundamental quantities and their units. We have a fundamental quantity and their units. So because of our time, we have our fundamental quantities, the units, fundamental units, and units abbreviations. So the first fundamental quantity we discussed earlier is the length. Length is defined as the interval between 2 points in space, and the unit of length is meter. As a small letter m, that is meter. Unit of length is in meter. Like I told you earlier, other units of length can be in centimeter, inches, and so on and so forth. So we have the mass as the second fundamental quantity. The unit of mass is kilogram, which is kg. We also have time. The unit of time is in seconds. That is small s. We have temperature. Temperature we discuss in our advanced class as the degree of hotness or coldness of a body. The unit of temperature is in Kelvin. That's upper class K. We have electric currents. we will also look into as a topic as the rate of flow of electric charge along a conductor. Electric current is measured in ampere. Is measured in ampere. That's class A. We also have amount of substances. Amount of substance. That's measured in mole. That's MOL, in mole. We also have the last one we're talking about today is the luminous intensity. Luminous intensity measured in candela, which is CD. Now I want us to master this fundamental quantity because we'll be using this in our next physics class and we'll be using them intensively for our derived quantity. We have length in meter, mass is kilogram, that's kg, time is seconds, temperature is Kelvin, electric current ampere, amount of substances is measured in mole, luminous intensity is measured in candela. These units will be used in both physics class and chemistry class. They are ways to communicate among scientists and they are also used in derivation of other quantities. So let's look at our derived quantities and their units. Derived quantities and their units. Derived quantities and their units. As I explained earlier, derived quantities are gotten from simple combinations of fundamental quantity and their units. Derived quantities and units. Now, let's quickly look at derived quantity, their derivation and units. Derived quantity, derivation and units. So today I'll be explaining both the derived quantity, how they are derived as derivation, and how we can get their units. So all students are expected to calculate and derive each unit for the derived quantity. The first derived quantity we're talking about is area. Area. What is area? Area is defined based on its derivation as length times breadth. Area is the length of an object times the breadth. As I explained earlier, length is defined as the interval between 2 points in space. Also, breadth is defined as the interval between 2 points in space. That defined based on the dimension as length times breadth, which means length has the unit of meter. Breadth will also have unit of meter. So if we have meter times meter, based on the law of indices, we're going to be having, it will give us m raised power, we have 1 m here plus another m. We're going to be having m square. So our area unit will be what? M square. That is meter square. Length has the unit meter, breadth has the unit meter. But a product of the 2 meter will give us meter square. We're going to be having m square based on their product. The second derived quantity we're looking at is volume. Volume also can be defined based on its derivation as length times breadth times height. Also, as breadth can be defined in terms of length, height can also be defined in terms of length. That is, length has the unit meter for fundamental quantity, breadth has the unit meter, height also has the unit meter. So when we do this up, we're going to be having m raised power 1 plus 1 plus 1, which will give us m raised power 3, known as m cube. So the unit of volume is meter cube. Unit of volume is meter cube. Another unit we should look at also for derived quantity is velocity. Velocity can be defined as displacement over time. We have all by distance. We have what we refer to as distance also. Distance or displacement. There are also interval between 2 points in space. Velocity. Now let's also talk about velocity and speed. Velocity and speed are like synonyms in English. Velocity is displacement over time, while speed is distance over time. Distance and displacement can be defined in terms of length, having the unit meter. So let's look at velocity now. Velocity is displacement over time. Velocity is displacement over time. We should note that displacement is distance traveled in a specific direction. I will put that again. Displacement here is distance traveled in a specific direction. And I told you also that velocity also have another regard for it. You can regard velocity also as speed. Let me be down out as speed. Speed is distance over time. Distance can be measured in terms of length, since the unit of distance is meter. Displacement here also can be measured in terms of length, since the unit of displacement also is meter. But the difference between displacement and distance is that displacement specifies direction, while distance does not specify direction. In advanced class, we learned about scalar quantities and vector quantity. Displacement here is standing as a vector quantity, while distance is standing as a scalar quantity. It has magnitude. It can be quantified but with no direction. So velocity here, for displacement here, we have the unit as meter, and the unit of time is seconds. According to indices, this m over s can be converted to as meter by changing this division sign to multiplication. The power here will be going up to raised power minus 1, since we have 1 seconds. So the unit for velocity will be meter per seconds. The reason I'm bringing this minus 1 up is because I'm changing the division sign here to multiplication sign. In physics, multiplication signs are represented with a small dot in between two alphabets, meter per seconds, which means meter over seconds, displacement over time. Also for speed, the unit of speed will also be meter per seconds. Converting it, we are going to be having meter per seconds per seconds. That is meter per seconds. Meter per seconds. We should make this per seconds. This, once we are having any object or any quantity, any unit having raised power minus 1, it means power of the object, power of the quantity. So this is per seconds. That is over seconds. Other derived quantities we are going to look at also in today's class is acceleration. Acceleration. Acceleration can be defined as the rate of change of velocity with time taken. That is velocity over time taken. So when we have acceleration here to be velocity over time. Acceleration is the rate of change of velocity or velocity over time taken. And let's not forget, if I'm asking you now, what is the unit of velocity? Velocity is not a fundamental quantity, it's a derived quantity. And the unit has been derived here as meter per seconds. I'm going to bring that meter per seconds here, meter per seconds. Then all over, our time is a fundamental quantity. And the unit of time is seconds. Now, back to our calculations. We are having meter here per seconds. If I'm bringing the seconds up, it will be given as dots per seconds, right? Now, according to the law I explained earlier, if we have 2 seconds, we can sum them together by having meter dots per seconds plus minus 1. So the having minus 1 plus minus 1 will give us minus 2, which is meter per second square. So we have per seconds, another per seconds, giving us 2 per seconds, which is per second square. Other derived quantity you'll be looking at. Other derived quantity we'll be looking at in today's class, we have force. 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 Force are guided to as push or pull. Force. Force is defined by its derivation as mass of the object times the acceleration, how far the object moves. The force determines how far the object has moved. So we have force equals to mass times acceleration. Now, I believe we can derive the unit of force together. That will be following my class. We can be able to derive this unit of force together. Our mass is what? Mass is kilogram multiplied by, I told you, I can represent multiplication sign with a small dot. Acceleration is a derived quantity, and the unit of acceleration is what? Is meter per second square. Meter per second square. Therefore, the unit of force will be kilogram meter per second square. Now note, units are regarded to as standard international units. They are called the SI units. A system international units are known as the SI unit. Force have a standard unit regarded to as Newton. So we use Newton to represent force. And the unit of force is Newton. As the standard unit of force is Newton. But also that unit for force is what we have derived. By derivation, the unit of force is kilogram meter per second square. So other derived quantity we are going to look at today is work. Work. I have a question. Let's look at this question together. A boy cycling a tire around and a boy pushing a mountain. Which are performing work between the two of them? Let's look at it together now. Work is done. Work done is done when a force is applied and a distance is moved. That is, a boy pushing a mountain that is being unmoved, and a boy playing around with a tire. The boy moving around is doing the what? The work, because the distance is being moved. That is, work is done when a force is applied and a distance is moved. That's why our work will be derived as force times distance. Work is derived as force times distance. That is, work is the product of force. It is the product of force and its perpendicular distance in the area of action of the force. That is, force times distance will give us work. This work is not done if a distance is not being moved or distance is not applied. Work is not done. So work is force times distance. And let's not forget that the unit for force is Newton. I told you. Then unit of distance is meter. Therefore, our work will be represented as what? As Newton meter. Also, just like force, work has a standard unit or SI unit, which is joules. That is upper class J, joules. Also, we can also divide or derive. We can also derive the unit of work using kilogram meter per second square for force. If we have our force as kilogram meter per second square times our distance is meter, force unit can also be kilogram meter plus meter will give us 2 meter. Meter square then per second square. So also another unit for work can be kilogram meter square per second square. But the standard unit or SI unit is what we'll be looking at and we'll be using. So we're using joules. For physics, we're using joules as the unit of work. Other derived quantity we'll be looking at today also. After force, work, we'll be looking at pressure. Also, another question I'll be asking is, a lady standing on a flat foot shoe and another lady standing on an heel foot shoe, which one is applying most pressure most? Who applied the most pressure? Is it the one on the heel shoe and the one on the flat surface shoe? Let's look at this together. Pressure is the drive or divine as force, the force applied over area. So pressure is defined as force over area. Now, which means the higher the area, you have what? Is it low pressure or high pressure? Let's look at this together. If our pressure equals to force over area, and let's write the unit for pressure. The unit of force is Newton. The unit of area, let's not forget, area is a derived quantity. The unit of area is meter square. So we have Newton per meter square. Let's now derive this. So we're going to be converting this to multiplication sign. We're going to be having Newton per meter square. This is per meter square. And I told you earlier, per meter square. So we're going to be having what here? Newton per meter square. Also, just like force, work, pressure also have a standard unit known as Pascal. Pascal. PA. Pascal. That's the unit of pressure is in Pascal. Other unit of pressure also, we'll be looking at it. We're talking about pressure as a course on its own. So here, our standard unit for pressure will be Pascal. Also, I can derive the unit of pressure from force as kilogram meter per second square. But I would like you guys to do that for me and drop the unit of pressure using kilogram meter per second square in the comment section. You can derive the unit of pressure from force as kilogram meter per second square over area as meter square. You can do that. So let's have the answer in the comment section. So we're using Pascal or Newton per meter square as the unit of pressure. Other derived quantity we will be looking at also is frequency. Other derived quantity we will be looking at today is frequency. What is frequency? Frequency can be defined also by derivation as the number of oscillation over time taken. Number of oscillation can be represented using signs by x whatever. So you can derive the unit of frequency by saying our number of oscillation here. I want to use dot to represent number of oscillation, then over time taken, and time is what? Seconds. By this, my unit for frequency can be represented as per seconds. If I'm not adding anything for number of oscillation, like I told you before, number of oscillation can be represented with x, with any alphabet. So therefore, the frequency unit will be per seconds. Also, frequency have its own standard unit. The standard unit for frequency is the hertz. HZ, hertz. Is the hertz. That will be all for today's class. So today we've learned about fundamental quantities and derived quantities and their unit, how to derive units, the basic units, and the SI unit also for each quantity. Thanks for watching. Thanks for your time. Can you support our good work by giving us a like, subscribe, and share? And don't forget, we'll be dropping each series every day. On Monday, we'll be for our chemistry series. On Tuesday, we'll be for our biology series. On Wednesday, for our physics series. On Thursday, for our mathematics. While Fridays will be for our questions and answer. And don't forget to turn on your notification button to get notified when we drop each lesson. Thank you. Bye.